Integration resulting in log functions. Suppose you're given the integral of du over u, which, by the way, is exactly 1 over u du. So basically it's asking, what do you take the derivative of to get 1 over u? And the answer is ln of the absolute value of u plus c. Of course, I could replace u with any letter of my choice. If you have dx over x, which is the same as 1 over x dx, this gives you ln of u plus c. Now, you might want to say, wait a minute. If you have 1 over x dx, this can be written as x to the negative 1 dx, which is all true. But remember, the integral of x to the n dx is x to the n plus 1 over n plus 1 plus a constant, but we can't divide by 0. That is, n cannot be negative 1. Negative 1 plus 1 is 0. So when this is negative 1, this is not true. If n is negative 1, that's not true. Oh, look at that. N is negative 1. So we know it's not going to be using that formula. So using a different formula, it makes sense. If I had to randomly guess what this is, I'm up a creek. There's a lot of answers, but you know what? The one answer I will not say is, remember, it does equal this, but I would not say it equals to x to the 0 over 0 plus c. That's one answer I wouldn't see. I might go with x cubed over 3 plus c. I have a better chance that that can be the answer. Why? This is an answer. This is nonsense. You can't divide by 0. Okay, so I argued why it's not of the form that this integral gives us. Is n cannot be negative 1. Okay, and another thing I want to point out is, I gave one way of writing the integral, the second way of writing an integral. I wrote it the same way using x's, but here is yet another way of writing it. Those three, this one, well, that's the same as the ones above, and this one. Okay, so all these three right here are different ways of writing the same thing. So know that so you don't think that they're different. Okay. The next problem we're going to look at is the integral of dx over x plus 5 dx. Well, if we let u equal the denominator, then, oops, too many dx's. Then du will just be dx. Okay, so there's an integral sign. Instead of dx, I can write du. Instead of x plus 5, I can write u. Ooh, I know this integral is ln of the absolute value of u plus c. Just substitute back in what u was, and you'll be okay. Plus c. Suppose you have the integral of x squared over 5 minus x cubed dx. This is also going to result in a log. How about we let u equal 5 minus x cubed? Well, then du will be negative 3x squared dx. Well, I have the x squared dx. I just need the negative 3. Well, you can plug in negative 3 as long as you multiply by the inverse. the multiplicative inverse. So in front we have 1/3 integral. All of this, just double check, yep, that's du. And all of this, yep, that's u. So this is negative 1/3 times this integral. But that integral I know well. It's ln of u plus c. So it's negative 1/3 ln of u plus the c. Let us try another problem. Suppose you have the integral of 3x over x squared plus 1 dx. Now, different people, they have different approaches to integrals, in solving integrals. It's your style. For example, it is, in theory, it's possible that one could look at an integral or solution to an integral that I claim that I wrote, and they can look at it and go, no, you didn't do this. This isn't your style. And my style is factor out constants. Factor out the constants. So you have this. Once in a while, I may get burnt because maybe I needed that 3 in the numerator. Well, if I let u equal to x squared plus 1, well then du is 2x dx. Well, I have the x dx, there it is. I just need to multiply it by 2. So I put a 2 in, I multiply the inside by 2, and I divide the outside by 2. So now I have 3 over 2, the integral of, well, that's du. I know it is. It says, whenever you see, these two lines tell me, whenever I see 2x dx, I can write du. And I do see 2x dx, so I write du. And in the bottom, I see x squared plus 1, well, that's u. Ooh, I know this integral. It's ln of the absolute value of u plus c. Oh, u is x squared plus 1. There it is. Make sure you account for everything in the integral when you convert from x's to u's. Suppose you have x plus 7 over x dx. Now, there's absolutely no reason to say, oh, I know this. I let the bottom be x, the bottom be u, and then du is dx, and then, so then, adding 7 to both sides, u plus 7 is x plus 7. Okay, so the top is the x plus 7, that's u plus 7. The dx, that's du, and the bottom is just u. But it's the same integral. All I did was change x's to u's. That didn't get me anywhere. Never make a change that says, oh, let x equal u, or let x equal t, or x equal y. It doesn't get you anywhere. So what do you do here? Well, it's customary when you have the top and the bottom being polynomials, and the degree of the top is either has a larger degree than the bottom, or is equal to the degree of the bottom. You should do the long division. So what is x plus 7 over x? I mean, you can go and do long division. I would just say it's x over x plus 7 over x, and that's 1. Okay, so this is the integral of 1 plus 7 over x dx. And whether you need to write it out as the sum, because it says plus, the sum of two different integrals, that's fine by me. The integral of 1 dx is x, plus this 7 can come out in front, and then you have the integral of 1 over x dx. Well, that's ln of x plus c. No substitution in this problem. Just in case you're going to say, well, you said I shouldn't let u be x, so I'll let u equal x plus 7. That's fine. So I have this, that's u, and du, that's dx. Ooh, so I know how to write dx in terms of u, and if I bring this 7 to the other side, then u minus 7 is x. So yes, I can rewrite that integral in terms of u. X plus 7 is u, that's what it says. Dx is du, that's what it says. X is u minus 7. This doesn't help at all. This did not help at all. I still have the degree of the top being at least as big as the degree as the bottom, and now it's harder to do the division. In fact, if somebody gave me that problem, I would think of the numerator as u minus 7 plus 7 all over u minus 7 du. Well, this division is going to give me 1 plus 7 over that. And these two, and that integral I can solve. Okay, so again, if you have a rational expression that is one polynomial divided by another polynomial, and the degree of the top is bigger than or equal to the degree of the denominator, long division. Okay, suppose you have this nice looking integral. X times the square root of x divided by 1 plus x squared square root of x. Now, you might guess, since we're in the chapter or section where we typically get integral of du over u, that we should call the bottom u. But the first thing I would do is I would multiply this out. Remember, x means x to the 1, and the square root of x means x to the half. You add the powers, you get x to the 3 halves dx in the top, and in the bottom you get 1 plus, well, x squared times the square root of x, that's x squared, and the square root of x is x to the half. When you add 2.5, you get 2.5, which is 5 halves. So it's 1 plus 5 halves, x to the 5 halves. Now, the thing is that 1 less than that is that. And that's what you do when you take the derivative. Make the power 1 less. If I let u equal that, then the differential du will be 5 halves x to the 3 halves dx. Well, I have this part sitting right there. All I'm going to do is put in the 5 halves and then pull out the reciprocal. So there's the 2/5 in front. Now all of this, I mean, it says it, all of this is du. These are the same. That's du. In the bottom, 1 plus x to the 5 halves. That's u. Ooh, I know this integral. It's 2/5 ln of u plus c. Now don't guess. Go back and look. U is 1 plus x to the 5 halves. Let us try one more integral. Suppose you have this integral. The integral of e to the x minus e to the negative x all over e to the x plus e to the negative x dx. Well, if you let u equal the denominator, just remember the derivative of e to the kx. The derivative of e to any power is e to that same power. That's easy. Times the derivative of the power, where k is just a constant. Okay, so then du, well, the derivative of e to a power is e to the power times the derivative of the power, which is 1. You don't have to write the 1. And I'm letting u equal e to the x plus e to the negative x, the denominator. Okay, plus the derivative of that. Well, the derivative of e to any power is e to that power times the derivative of the power, which is negative 1. That's what made the addition sign negative. And all of this gets times dx. Ooh, that's exactly what I have on top. Exactly what I have on top is du. And exactly what I have on the denominator is u. Look at that. So we get ln of the absolute value of u plus c, where that's u. E to the x plus e to the negative x. Okay, basically you're going to have some function in the bottom, and you're going to have the derivative of the function du on the top. So if I call that v, well, let's call this x, okay? Let's call it x. All the variables here are simply x. So you have f of x dx over f prime in the top. Well, if I call that u, okay, so that's u in the bottom, well then du would be the derivative of f of x dx. Ooh, that's what I have on top. That's du. Whenever you have that, it's ln of f of x, ln of u, which is f of x, plus a constant. You have u in the denominator, and du on top, ln of u.